This is J0030, a type of dead star called a pulsar, located about 1,100 light-years away in the constellation Pisces. Observing J0030 in X-rays, astronomers have now made the most precise and reliable measurements of any pulsar size. And they've discovered that J0030's appearance differs dramatically from textbook depictions. NASA's Neutron Star Interior Composition Explorer, or NICER, is a telescope on the International Space Station. NICER makes extremely detailed X-ray measurements of neutron stars, and its data provided this unprecedented glimpse of J0030. A neutron star is the crushed core of a massive star that exploded in a supernova. Pulsars, like J0030, are rapidly spinning neutron stars that sweep beams of energy across our line of sight, much like a lighthouse. A pulsar is so dense that its gravity bends the fabric of space-time around it. NICER's precise X-ray measurements allow scientists to take advantage of this effect, to see light from the far side of the pulsar. This is a pulsar-sized object about 16 miles across, but with much less mass. We only see light from the side of the object nearest to Earth. But as its mass increases, the object warps space-time and acts like a lens to show us light from the far side. This has the strange effect of making a pulsar look bigger than it really is. The more mass an object of a given size contains, the more it distorts space-time, and the more we see of its far side. Textbooks show pulsars with two hot spots on the surface, directly opposite each other at the magnetic poles. As the pulsar spins, the spots come in and out of view, creating regular changes in its X-ray brightness. If the pulsar's mass is low, the spots disappear when they rotate to the far side. But if the mass is high enough, the hot spots may never completely disappear. Using NICER data, two teams of scientists examined different models for the shapes and even the number of hot spots on J0030. Both arrived at the same conclusion. The pulsar is around 16 miles across and about 1.4 times the Sun's mass. This represents the most precise measurement yet of a pulsar's size, with an uncertainty of less than 10%. The spots themselves don't match the textbook image, though. From Earth, we look down onto J0030's northern hemisphere. Both teams say there are no spots there at all. Contrary to the simple magnetic dipole model, all the spots appear in the southern hemisphere and are not necessarily in shapes we might expect. One team, led by researchers at the University of Amsterdam, suggests J0030 has one small circular spot and another long crescent-shaped one. The other team, led by researchers at the Universities of Maryland and Illinois, finds two oval hotspots. Their sizes, shapes, and locations closely match those derived from the other model. However, the Maryland-led team also finds a third, cooler spot located slightly askew of the pulsar's south rotational pole, just at the edge of our view of the pulsar. Scientists are still trying to determine why J0030's spots take on these shapes and arrangements, but for now it's clear that pulsar magnetic fields are more complex than originally assumed. NICER's measurements of J0030 have opened a new chapter in our understanding of neutron stars. As it continues to study other pulsars, we'll learn even more about the common characteristics and individual quirks of these incredible objects.